Section 4.2. The beginning of this section, we want to talk about two events, joint or disjoint. Let's look at this example. Let's say you have two baskets, and on first basket, basket A, there are 5 marbles. We label those marbles 3, 4, 7, 8, 10. And the second basket, there are 6. And we label those marbles 5, 6, 7, 10, 12, 19. Now, what is intersections? Intersection means when you overlap these two, what numbers do they both share? So when you overlap these two, they both share number 7 and number 10. So this is intersection, and this is the symbol we use. What is union? Union is you threw all the marbles into one basket, but you do not repeat a marble more than once. So call it union, and this is a symbol we use. So you see here, A union B means you have all the numbers inclusive, but no number is repeated. So the first one, intersection, that they both share two numbers, is the joint events. Now, let's look at the second examples. On this example, we have these two baskets. One has 3, 5, 7, 10. The second one is 4, 6, 8. You see, there is no number in common. So what is the intersection? None. So when you overlap these two, you don't see any overlap here. So in that case, they call it disjoint. So that's the difference between joint and disjoint. And then we have examples here. And two events are disjoint if they cannot occur at the same time. So here, arriving late, arriving early. So these are examples of disjoint. You either come late or early. Selecting someone who believes in UFO and somebody who believes in devil. Okay, so it's just the difference. So two disjoint events if they cannot occur at the same time. So it's like somebody is Democrat, so you either are Democrat or Republican. Or selecting someone treated with certain medication, someone that has no medication, and so on. So these are good examples of two events that are disjoint, no intersection. Next is talking about dependent or independent. Let's assume on this example that there are 8 students in one class. Out of these 8 students, there are 5 males and 3 females. If I'm outside of the classroom and randomly ask one of the students to leave this room, what's the probability of the person who's leaving the room is the female? It's 3 out of 8. 8, remember the probability, the bottom, the denominator is always the total number. So probability of the first person leaving this room is the female is 3 out of 8. Now, with replacement is, I ask the person return to the class. So number doesn't change. Then if I call for the second time, still would be 3 over 8. It means these two are independent. Nothing changed when the person returned to the class. Now, these are with replacement. What is without replacement? Without replacement is if the person stay outside of the class, so when you ask for the second part, number reduced to 7, and number of female is 2 out of 7. So this is dependent, meaning the second event depend on the first one. Whatever change happened to the first one, it would impact the second one. So these are the difference of dependent or independent. Independent, if the occurrence of one does not affect the probability of occurrence of the second. Dependent, if occurrence of one does affect the probability of occurrence of the other ones. Now, these are some other examples here. Determine if two events are dependent or independent. When a month is randomly selected and ripped from the calendar. So when you first, it's if you want to select a month, that would be 1 out of 12 because every year is 12 months, 1 out of 12. But if you go for the second part, if July is not there anymore, means what? Means you have 11 pages left. So it would be 1 over 11. So these are example of dependent, means the second one changed. So the first, there are 12 pages on the calendar, but the second one, since one page is missing, there are 11 pages. So you select 1 out of 11. Another what is example of independent? When a baby is born, is a girl, and the single die is rolled, the outcome is 3. So the first event is, what's the probability of having a girl where the baby is born? 1 out of 2. What's the probability of having number 3 when you roll a dice? 1 out of 6. These are independent. They have nothing to do with each other. One is baby, the other one is other. There are 2 questions in the test. First question is false or true. The second question is multiple choice. Okay, so again, these 2 events are independent. Whether you come up with the right answer on the first questions or the second questions, then both questions are independent. So what's the right or wrong is 1 over 2. Is it true and false for the first one? So when you want to select the answer is either true or false, 1 out of 2. The second part, there are 5 choices. When you select the correct one is 1 out of 5. So when you multiply, this is 1 over 10. Again, these are independent. They have nothing to do with each other. These 2 questions, whether you come up with the right or wrong, would not impact the second one. So this sign means probability of A and B. Intersection means B/A means, this slash means at the denominator, this event happened first and then the second event. That's what it means. All right. 8 girls and 5 boys are in the class. If one randomly select 2 people, what is the probability of selecting 2 girls? Probability of A and B is probability of A times probability of B. So 8 over 13, there are 13 boys and girls, and probability of girl is 8 out of 13. If it's independent, the second one, because it's with replacement means independent. Second one also is 8 over 13. Now, what is without replacement? Without replacement means you don't put that back, so the numbers are not 13 anymore. Number is 12. So in that case, the number of girls reduced from 8 to 7. So 8 over 13 times 7 over 12. This is without replacement. Now, for these multiple choice questions, I put the answers here. Now, here the first page is blank, so you could practice, and then the answer is here. Now, there is a formula for the OR that if you have probability of A or B, if there is a word or, is probability of A plus probability of event B minus probability of intersection A and B. In problem number 4, there is no between B and B1, there is no intersection because these are two events that are independent. So there is no intersection when they both are independent. Again, number 7, 8, and 9. Number 7, in a computer, instant messaging, respondent number asked to choose the most fun way to flirt, and it finds that, excuse me, P of D is given. What is P of D bar? Again, the formula is this, that P of D is 0.60, which is the direct. D bar is opposite of that. This does not choose a direct in person. So D is the correct answer. Remember, P of D and P of D bar, these are always opposite. So if this is a direct, the other one is indirect. The same for number 8. W is intoxicated. W bar means not intoxicated. So for that, if you want to find the probability of driver intoxicated, is 9 out of 662. Which is that number. This number is given in the problem, probability of intoxicated. And what is probability of W bar means non-intoxicated. Then is 1 minus. So again, both is based on the formula of the PW plus PW prime equal to 1. So if you have 1 and you want to find the other one, all you need to do is subtract from 1. Now, these are the type of problems that when you are given a table, the very first thing you need to do, you need to add all the numbers on the first and the second row, write it here, and all the numbers in the first, second, third, and fourth column, and write it there. And then look for probability. So this is a blank page. Now, here, so I add all the numbers here. Order accurate is 990. Non-accurate is that, and then I add all the numbers on each column. Now, find the probability of getting food that is not from restaurant A. So here, if you notice, all restaurant A, B, C, D, the total is 1135. How many of them are not from A? From A is some of these 3, right? So would be, if I take 370, subtract from 1135, or if I just add these 3 numbers, because these are restaurant B, C, and D, then you put it here. These are other restaurants than A. All the restaurant, not including A. That would give you the probability of food from B, C, D, not A. There are 2 other problems like that here. Again, I'll put it here. So you add all the numbers row. What is the probability of getting order that is not accurate? How many orders are not accurate? When you look here, order not accurate is 145. 145 out of the total number. Or in this one, find the probability of getting order that is not accurate or is from the restaurant C. See, when it comes to the or, this is again formula. Probability of not accurate or from restaurant C. Again, remember, for that, we use the formula of the P of A or B, which is probability of A plus probability of B minus intersections the letter A and B might be different thing here. So probability of not accurate or from restaurant C is probability of not accurate, probability of restaurant C minus intersections. Not accurate. You look here, not accurate is 145. Restaurant C is 274. And now the last one is intersection, not accurate and from restaurant C. Not accurate and from restaurant C. So you find the intersection, C and not accurate. This is and, which is 37. Again, not accurate from here and restaurant C give you that number, intersection 37. And that give you the answer. The same thing here. Now, this is the example of with or without replacement. With or without replacement. All right. So if two orders are selected, find the probability that both are from restaurant D. Assume selection are with replacement. Restaurant D, there are 149 orders. So 149, since it's two order, with replacement is nothing change. The second part is without replacement, means when you do the first order, the second order is changed. So it dropped 1. This is without replacement. So you drop 1 from the total of 149 and 1 from the total. The same thing for this problem, it's very similar. There are two events. The first one is with replacement. The second one is without replacement. So without replacement, they drop 1. These problems are all very similar. And this one, find the order from restaurant A or B that are not accurate. So there are 3 or here. A or B or, see, or there are 3 of them. So it would be probability of A plus probability of B plus probability of not accurate. Then you have to find intersection of each. A and B, there is no intersections because both are here. You cannot overlap A and B. But what is A and not accurate? Probability of A and not accurate is 31. See that? A come from here, overlap with not accurate is 31. Or B and not accurate. B, intersection of B and not accurate, you could overlap is 60. And you could find probability of each separately. There are 369A, 338B, and how many not accurate? 135. Again, this is an example of with replacement. You see? All from 3. There are 3 different order. 1, 2, 3. You could also write it like this if you want to do calculations. All from restaurant C. Restaurant C, there are 271 order. They all are with replacement. On this one, it said 143 subjects, they have a positive test result. 21 false positive test result. So out of 143, but positive test result 21 was false, means 21 they didn't have positive. Again, 150 negative test result, 4 was false negative test result. So altogether, how many samples? 300. How many did not use marijuana? So he said here, first one is 21 was false positive result, means they didn't use it. The second one, out of 157, the difference of this, because 4 was false, this 4 actually did use it, so the remaining did not. So remaining of that plus that is 174. And the last one, probability of the one that did not use. So sum of these two is here. And they are disjoint here. And the rest is a multiple choice that the answer is at the end of this. You could practice on that.